Ever wonder what happens when the cosmos unveils a secret we're not ready to grasp? These are the moments that redefine our place in the universe, sparking a fire in our collective soul. Picture a silent voyager gliding through the shadows of our solar system, defying every rule we thought we knew. This isn't just a chunk of ice or rock. It's a cosmic enigma, a riddle wrapped in starlight, daring us to question reality itself. Meet 3IATLAS, the third confirmed interstellar visitor that set the world ablaze with wonder, skepticism, and a thrill that tingles down the spine. If your heart's racing already, smash that like button and let's embark on this journey together, because this story might just change how we see the stars. Imagine the quiet hum of observatories perched on misty peaks, their telescopes like giant eyes piercing the night. It's mid-2025, and astronomers at the Asteroid Terrestrial Impact Last Alert System, ATLAS, in Hawaii, spot a faint flicker in their data, a speck dancing against the eternal backdrop of stars. At first, it's just another blip, but as the numbers align, pulses quicken. This isn't a local asteroid. It's an outsider, born beyond our sun, slicing through our solar system on a hyperbolic orbit. Named 3I/ATLAS, it's the third interstellar guest after Oumuamua in 2017 and 2I/Borisov in 2019. As of October 25th, 2025, it's hurtling toward its closest solar approach on October 30th, at 1.4 astronomical units, about 130 million miles, close enough to feel the sun's warmth, yet distant enough to guard its mysteries. The discovery sends a shockwave of excitement across the globe. From Tokyo's neon-lit observatories to Chile's star-dusted deserts, scientists and dreamers unite. Telescopes in Hawaii's Mauna Kea, Chile's Very Large Telescope, and the orbiting James Webb Space Telescope pivot to track this wanderer. Early images reveal a glowing coma, a shimmering veil of gas and dust swirling in the void. But here's the twist that hooks you. This isn't a typical comet's erratic sputter. Its venting is steady, almost deliberate, releasing water, carbon monoxide, and dust in ways that defy the weak sunlight at its distance. Spectrographs paint a strange portrait: high carbon dioxide, complex hydrocarbons, and a curious absence of sodium lines that usually scream comet. The data sparks a whirlwind of awe and confusion. Is this a pristine relic from another star, carrying secrets of alien worlds? Or is there something more? A hint of intent in its graceful motion. I feel that electric spark of discovery, the same thrill that must have gripped ancient stargazers under Mesopotamian skies. It's a reminder. We're all explorers, bound by the cosmos. If this hooks your curiosity, drop a comment with your first memory of gazing at the stars. Let's share that cosmic connection. The stage is set, and the data pours in like a cosmic storm. Let's dive into the clues that turn this blip into a global obsession. Picture a symphony of observatories, each telescope a note in a crescendo of discovery. By late summer 2025, 3I/ATLAS is under a global microscope. The Pan-STARRS array in Hawaii tracks its brightness daily, revealing an outgassing so consistent it feels choreographed, far beyond what models predict for an object 1.4 astronomical units from the sun. It's shedding water, carbon monoxide, and dust in vast plumes. Yet its light curve is smooth, not the wild heartbeat of a typical comet. The James Webb Space Telescope's infrared sensors detect heat emissions that pulse subtly, as if the object is regulating its temperature, not the chaotic glow of a tumbling ice ball, but something poised, almost alive. Dive into the spectra, and the plot thickens like fog over a midnight sea. Reflected light shows oddities: elevated CO2, hydrocarbons hinting at organic richness, and that baffling lack of sodium. Radio telescopes listen for natural emissions, but hear only silence, save for faint thermal irregularities that defy neat equations. The trajectory? Slightly off from gravity's script, as if invisible forces nudge it. Models of irregular rotation or bursty jets falter. The surface is smoother than expected, with fewer icy patches glinting in starlight. As of October 25th, 2025, New images show a massive, jet streaming sunward, a dramatic flare that's both breathtaking and bewildering. This isn't just data, it's a roller coaster of human emotion. Imagine researchers in labs worldwide, clutching coffee cups, debating late into the night. For us, it's a humbling mirror. A speck from the stars challenges our certainties. It's like the universe is whispering, look closer. If this mystery has you gripped, share this video with a sci-fi loving friend. Let's spread the cosmic intrigue. As the evidence mounts, one voice dares to ask the unthinkable, igniting imaginations worldwide. In the hallowed halls of Harvard, where ideas spark like stars in a nebula, astrophysicist Avi Loeb steps boldly into the cosmic spotlight. Known for shaking the scientific world with his theories on Oumuamua, Loeb, in his July 2025 paper, Is the Interstellar Object 3IATLAS Alien Technology? Published in Nature Astronomy, drops a bombshell. 3I/ATLAS might not be a mere comet, but a crafted object, possibly masking its true nature. His evidence? The steady outgassing, eerily consistent at 1.4 astronomical units, where sunlight should barely tickle the ice. Orbital tweaks, so subtle yet precise, suggest a nudge beyond gravity's pull. Spectral data, brimming with reflective hints, perhaps metallic or crystalline surfaces, whispers of something engineered. Loeb envisions a probe, cloaked in a fuzzy coma of gas and dust, its small nucleus hiding artificial intent, slipping through our solar system like a silent observer from a distant civilization. The emotional weight of this claim is staggering. Picture a young astronomer in Nairobi, staring at her computer screen, heart pounding as she reads Loeb's paper, wondering if this is the moment humanity meets its cosmic neighbors. Or a grandfather in rural China, telling his grandchildren tales of starships, inspired by news buzzing through WeChat. Loeb's hypothesis isn't a wild leap. It's grounded in patterns, statistically unlikely for a natural comet, he argues, citing a 2025 study showing only a 0.1% chance of such stable emissions without external influence. As of October 25th, 2025, with 3I/ATLAS nearing solar conjunction on October 21st and perihelion on October 30th, the world holds its breath. Will it reveal structured emissions, perhaps a narrow band signal, or continue its enigmatic dance? Critics, from MIT's dusty lecture rooms to Oxford's sleek observatories, push back hard. They argue gas jets can mimic propulsion, as seen in Comet 67P/Churyumov-Gerasimenko's Rosetta mission data. Sunlight pressure, they say, can nudge trajectories, per 2024 models of interstellar dynamics. Dust tails can skew brightness, fooling even the sharpest telescopes. Yet even skeptics pause. 3I/ATLAS's smoothness, its lack of chaotic outbursts, stretches these explanations thin. In Mumbai, a student debate club dissects Loeb's claims, their voices echoing with excitement. In Paris, a cafe buzzes with locals sketching comet theories on napkins. This isn't just a scientific spat. It's a global conversation, stirring hope, fear, and humility. Are we on the cusp of answering, are we alone? If Loeb's daring vision sparks your imagination, hit that like button and comment, alien probe or natural wonder. Let's ignite the debate across the globe. The debate rages, but science demands balance. Let's explore the natural explanations vying for supremacy. Science is a battlefield where ideas clash, and evidence holds the crown. As 3I/ATLAS captivates the world, comet experts from every corner, Sydney to Sao Paulo, craft models rooted in the physics we trust. One theory paints 3I/ATLAS as a loosely bound aggregate of ices from a carbon-rich alien star system, packed with volatiles like CO2 and methane that sublimate steadily under even faint sunlight. This explains the eerily even venting, like a slow-release symphony rather than the chaotic bursts of local comets. Imagine a researcher in Cape Town, her eyes gleaming as she models this alien ice ball, its structure a relic of a distant stellar nursery, perhaps formed near a red dwarf star billions of years ago. Another hypothesis dives deeper. Subsurface pockets of trapped gases, locked beneath a dark, tarry crust, vaporize slowly, producing that subtle orbital nudge without invoking design. Picture a grad student in Tokyo, running simulations late into the night, her screen glowing with 3D models of layered ices, each layer a clue to a foreign world's chemistry. Rotational tumbling enters the fray, a complex, multi-axis spin making the object's motion appear smoother, much like 2I/Borisov's surprises with its high CO output and odd dust grains, per 2019 ESO studies. As of October 25, 2025, fresh images from Chile's ALMA array show the jet's alignment, possibly a result of balanced gas jets rather than intentional control, aligning with a 2025 Astrophysical Journal paper modeling symmetric outgassing. These explanations aren't dry. They're nature's artistry, a testament to the universe's knack for surprises. Simulations evolve daily, tweaking gas flows, particle sizes, and spin rates, inching closer to the data. In a small Alaskan village, a teacher uses 3IATLAS to inspire her students, drawing parallels to Earth's auroras, nature's way of defying expectations. Globally, the debate unites. A Moroccan stargazing club hosts a webinar, connecting with peers in Argentina to compare theories. Emotionally, it's grounding. Amid uncertainty, we find patterns that weave us into the cosmos. As of October 2025, social media platforms report 5 million number 3 IATLAS posts, from Indian artists painting its glowing coma to Russian poets penning odes to its mystery. If these natural twists hook you, share this video with your community. Let's spark curiosity worldwide. Drop a comment. What natural theory do you buy? Let's keep the conversation alive. History's lessons anchor this tale, linking 3I/ATLAS to its cosmic predecessors in a grand narrative. No story stands alone. It's a thread in the vast tapestry of the cosmos. 3I/ATLAS echoes the saga of Oumuamua, the cigar-shaped wanderer of 2017 that zipped through our system, accelerating mysteriously without a visible tail, sparking Avi Loeb's light sail theories in his 2018 Scientific American article. Then came 2I/Borisov in 2019, a textbook comet with chaotic gas plumes and dust, proving interstellar visitors could be icy nomads, per ESO's 2020 analysis. 3I/ATLAS bridges them. Borisov's vibrant activity paired with Oumuamua's poised, almost deliberate motion. As of October 25, 2025, studying this trio sharpens our cosmic nets. Surveys like ATLAS and Pan-STARRS now detect anomalies within days, with spectral coverage spanning visible, infrared, and radio, per a 2025 NASA report. The differences are as telling as the similarities. 3I/ATLAS's emissions are steadier than Borisov's erratic bursts, suggesting origins in a stellar system with unique chemistry, perhaps a region rich in stable ices formed under low-temperature conditions, as theorized in a 2025 monthly notices of the Royal Astronomical Society paper. Imagine a scientist in Brazil, her heart swelling as she traces 3I/ATLAS's path, connecting it to Oumuamua's fleeting visit, which she watched as a student, or a Bedouin elder in Jordan, weaving tales of these wanderers into stories of desert nomads shared under a starlit sky. The trio's legacy refines detection. Oumuamua slipped by post-perihelion. Borisov was tracked with limited tools, but 3I/ATLAS enjoys a global watch, with over 50 observatories contributing data by October 2025, per IAU records. Emotionally, this lineage is a beacon of wonder, chipping away at our cosmic isolation. From African savannas where villagers host star parties to Arctic tundras, where Inuit elders blend 3I/ATLAS into oral traditions, humanity unites under one sky. Social media buzzes. Hashtag interstellar visitors trends with 2 million posts, from Japanese haikus to Mexican murals depicting these cosmic guests. Each visitor adds a puzzle piece, hinting at the galaxy's bustling traffic. If this historical thread pulls at your heart, hit like and comment. Which interstellar visitor fascinates you most? Share this video to connect dreamers across borders. Let's keep the cosmic story alive. As 3I/ATLAS dominates, a local comet offers a dazzling contrast, grounding our tale in familiar splendor. As 3I/ATLAS weaves its enigma, another celestial performer takes center stage. Comet C/2025 R2 SWAN, discovered in early 2025 via the Solar and Heliospheric Observatory's SWAN instrument. By October 25, 2025, it's a naked-eye spectacle in evening skies, its emerald coma glowing with diatomic carbon and cyanogen, brightening predictably as it nears the sun. Across the globe, from Australian outback stargazing parties to Brazilian community telescope nights, amateurs clutch binoculars, gasping at its dynamic tail stretching like a cosmic brushstroke. Its behavior is textbook. Strong molecular emissions, a dust plume that dances with solar winds, all aligning with models honed over decades. SWAN's brilliance isn't just aesthetic, it's a scientific anchor. Its data calibrates instruments, ensuring 3I/ATLAS's oddities aren't detector glitches. The contrast is stark. SWAN's chaotic bursts versus 3I/ATLAS's serene pulses, its predictable molecular glow against the interloper's muted emissions. As of October 25, 2025, SOHO's latest images show SWAN's tail splitting subtly, a natural response to solar radiation, while 3I/ATLAS's jet remains eerily aligned. This comparison is like a cosmic control experiment, with SWAN as the familiar friend and 3I/ATLAS the mysterious stranger. Imagine a Peruvian farmer pausing at dusk, spotting SWAN's green glow, feeling connected to astronomers in Japan analyzing the same sky. It's a universal moment, binding humanity under the stars. This chapter carries emotional weight, joy in shared wonder, comfort in the predictable. SWAN's visibility sparks global events. In South Africa, schools host Comet Nights. In Canada, Indigenous communities weave its glow into oral traditions. As of October 2025, social media buzzes with hashtag Comet SWAN photos, from India's rooftops to Scotland's highlands. It's a reminder that while 3I/ATLAS challenges our minds, SWAN warms our hearts, uniting us in awe. Have you spotted SWAN's green shimmer? Step into the buzzing heart of scientific discovery. University lecture halls, virtual conferences, and observatories alive with fervor. By October 2025, 3I/ATLAS fuels intense debates. Avi Loeb stands firm. His July 2025 paper citing statistical unlikelihood of natural causes for the object's steady venting, orbital tweaks, and reflective spectra. He imagines a probe cloaked in a fuzzy coma, its small nucleus hiding artificial intent. Critics, from MIT to Oxford, counter with rigor. Gas jets can mimic propulsion. Dust tails skew brightness. Sunlight pressure nudges paths. Yet they admit, 3I/ATLAS stretches comet models thin. Picture the scene, a Tokyo symposium where astronomers trade spectra, brightness graphs, and thermal maps. Voices rising with excitement. In California, grad students run AI models, sifting thousands of spectral lines for hidden clues. Results? Faint infrared absorption hints at complex organics, not unheard of, but suggestive of alien chemistry. No metal alloys, no repeating radio pulses, just tantalizing ambiguity. The debate spills into public forums, from Cairo's science cafes to Sydney's planetariums, where enthusiasts parse headlines. Media sometimes sensationalizes, but the buzz fuels progress. Grants pour in, with $50 million allocated in 2025 for interstellar surveys, per NASA reports. New instruments, like upgraded radio arrays in Australia, prepare for monthly detections. This isn't discord, it's science's heartbeat, pulsing with curiosity. From Chinese space agencies to European collaborations, it's a global quest. Feel the fire? Hit like and comment, what's your take on the debate? Share this video to keep the momentum alive. As 3I/ATLAS nears the sun, anticipation builds like a symphony reaching its climax. The clock ticks toward October 30th, 2025, when 3I/ATLAS reaches perihelion, its closest dance with the sun at 1.4 astronomical units. Astronomers worldwide are poised, telescopes locked on this fleeting guest. Will its emissions spike, signaling normal sublimation, or remain steady, hinting at something extraordinary? As of October 25th, 2025, the object's massive sunward jet, captured by Chile's ALMA array, grows brighter, yet its alignment stays eerily precise. Advanced imaging systems, like Hawaii's Subaru telescope, target dust particle sizes, tail orientation, and spin rate, while radio dishes in New Mexico listen for narrow band signals. Data precision is unmatched, brightness variations tracked to 0.01%. The stakes are cosmic. A spike in gas output would align with comet physics, calming speculation. Steady emissions? That's a game changer, suggesting control or unknown processes. Imagine the tension in observatories. A Kenyan astronomer refreshing data feeds, a Russian team calibrating sensors under starlit skies. A flyby mission is a dream. 3I/ATLAS's 90,000 plus kilometers per hour speed and steep path make it a tough target. Yet, as of October 2025, NASA's Jet Propulsion Laboratory explores redirecting a lunar probe for a long-shot pass, per recent briefings. Simulations for future intercepts, inspired by Oumuamua and Borisov, shape strategies. Early warning systems now detect objects within days. Emotionally, it's a global vigil. From Mexican villages hosting watch parties to European kids sketching 3I/ATLAS, humanity's united in anticipation. This moment feels like holding your breath before a leap. If this countdown excites you, comment, what do you hope we find? Share this video to rally more cosmic explorers. The final chapter gazes forward, dreaming of missions sparked by this enigma. 3I/ATLAS isn't just a visitor, it's a catalyst, igniting dreams of exploration. As of October 2025, NASA and the European Space Agency accelerate plans for interstellar interceptors. Concept designs, detailed in a September 2025 ESA report, envision compact probes in Earth's orbit, ready to chase future objects with high-speed propulsion. These comet chasers could reach a target within months, before it flees the inner solar system. 3I/ATLAS's data, its odd composition, subtle spin, and thermal pulses, shapes their toolkit. Dust collectors for chemical sampling, high-res imagers for surface mapping, spectrometers for alien ices. Picture the human stories behind this push. A Brazilian engineer designing propulsion in São Paulo, inspired by childhood stargazing. A Chinese student in Beijing coding AI to predict orbits, dreaming of distant worlds. Budgets swell. NASA allocates $200 million for 2026 to 2030 interceptor studies, per recent congressional reports. The vision? A network of sentinels, from Japan's Hayabusa team to India's ISRO, ready for monthly interstellar arrivals. Each visitor, like 3I/ATLAS, could unveil chemistry or physics from alien systems, piecing together the galaxy's puzzle. Emotionally, it's a beacon of hope. From Moroccan desert observatories to Alaskan aurora watchers, we're united in reaching out. 3I/ATLAS, whether natural or not, reminds us, the cosmos is alive with possibility. As it fades into the dark, its legacy endures, pushing us to chase the next wanderer. If this vision inspires you, smash like, share with dreamers worldwide, and comment, what's the next cosmic mystery you want solved? Let's keep exploring together. This cosmic saga doesn't end. It's just the beginning. Thank you for joining this journey through the stars.